Welcome to the very first episode of the C programming. In this course, we are learn about the various aspects of C programming. Now, I'm going to assume that you know nothing about computer, and I'm going to start from the most basic parts of computer, and I'm going to lift you people up to the most advanced technologies using C programming. Now, Now we all know that C programming has a vast application in everyday life, and this course will actually help you to understand the extent of im- uh, implementations that this program makes, or maybe the capacity it has to make implements. This is the very introductory lecture or video. So here we are going to study about the C programming introduction, history and requirements. So let's proceed. Now, before we start any topic, we always give an introduction. There is an introductory speech before everything. So we are going to also follow the same thing. Now, computers. Now, it is obvious that I'm not going to tell you, I'm not going to start from what is compilers, but I'm going to start from what is computers, because it's the basic question that comes to your mind. It is a very tricky one. Now, what is computer? Now, if you ask somebody what is computer, you're gonna see that the answer is very vast. But when first computer was introduced, when vacuum tubes were used to build computers, if at that time you would have asked somebody that what is a computer, that person would have said that a computer is a device which makes calculations easy. But nowadays, if you ask a kid that, hey, what is computer? That kid is gonna answer you that a computer is a device in which you can play games, you can watch movies, you can watch cartoons, you can listen to music, you can surf the net, you can watch videos on YouTube. So this is the extent of computer. Computer is expanding and will go on expanding in the next maybe few centuries. So since we are studying the course of C programming, so the term programming comes to your mind. So now we are going to introduce you to the term programs. Now, what are programs? Programs are often used analogously with code. Many people say I'm a coder. But what does this code means or program mean? Simply, or maybe in simple words, a program means a set of instructions that the computer follows to execute something and give you the desired result. Let me tally this thing with a real life example. Suppose you are making a cup of tea. Now, to make a cup of tea, you have to follow a set of instructions. For example, step 1, light up the oven. Step 2, place a bowl on fire. Step 3, pour some water in the bowl, etc., etc. So these are the instructions, and at the end of the execution of every instruction, or maybe performing every instruction, you are going to see, or you are going to get the desired result. So this is what a program is. Now we have different programming languages, right? Like we say Java is a programming language, C is a programming language, Fortran is a programming language, C++ is a programming language, and some geek says Python is a programming language. But what are these languages? I mean, why do we say them language? because they are grammars of computer. Now the languages of computer are divided into three parts: high level, low level, and assembly level. Now we all know that computer interacts with its components using zeros and ones. 1 implies a high signal or a high voltage, and 0 implies a low signal or a low voltage. Now as a human being, you cannot instruct a computer in terms of ones and zeros. If you had to say display this message, if this was your instruction, and imagine you had to instruct the computer in terms of ones and zeros, how much hectic the job would have been. So to make this thing easy, the computer scientists have developed high-level language. High-level language because these languages are not understood by the computers directly. They require some kind of translator, which in computing terms are known as compilers, to convert them into low-level language. Low-level languages are languages which the computer does understand. So high-level language is a language which the user or human beings understand, but the computers doesn't understand. And low-level language is a language which computers understand and most of the human beings doesn't understand. Now there is another term which is known as assembly language. Now let's get back to making tea. In that making of tea, we would have said add sugar. But forget about add sugar. I told you to add water into the bowl. Now how will you add water? There are different steps. You can to add water, you have to follow different steps. You have to take a water bottle, you have to open the cap of the bottle, you have to pour the water. So these are the three steps you need to follow, but I am not mentioning them because those are implied. But computer is not that intelligent. You have to instruct each and everything. But as a user or as a programmer, it is very hectic to instruct each and every instructions. So we often use some keywords which have some implied meanings or implied steps, hidden steps inside it. So these hidden steps are actually added on to the high level language during execution. For example, if I say print a particular message, say I say print hello world, I instruct this to computer. Now to print, the computer follows a set of instructions which I am not mentioning, but it is getting from the assembly level language. From that assembly level language, it is actually getting, after getting the code from the assembly level language and adding it up to the high level language, it is then converted to the low level language by the compiler. That means, in short, high level language plus low level language, high level language plus assembly level language, when converted, gives you a low level language, a perfect low level language. Now what is the definition of C language? C language is a high level language. C language is a high level language with some low level attributes in it, with some low level features in it, which have been arbitrarily or knowingly kept in the language. It is an intentional move by the creators of the language. Now coming to the creators of the language, we need to study the history of this language. C was developed in 1970s by one guy named as Dennis Ritchie at Bell Laboratories, which is now known as AT&T Laboratories. C was actually an outgrowth of two earlier languages called BCPL and B. In fact, the name C comes because C comes after B. So since its predecessor was B, so this language was named C. Now this language was mainly used or maybe um, written or maybe constructed or developed to make an operating system which is now commonly known as Linux or Unix. But the earlier commercial implementations of C had some incapab- incompatibility issues. That means it was not compatible in every devices, because there were various C compilers, there were various translators, so each of them used different language or maybe different grammatical language. But later this problem was diminished by American National Standard Institute's ANSI. In 1980s, another high-level language was named C++, was developed by Jarne Starstrup. It's a strange name, Straustrup. I never am able to pronounce this name, but this guy actually developed the C++. So this is a brief history of the C language, and this history actually changed the future of, of the computer science, because after C language was launched, computer science developed in a vast manner, and most of the present day languages like Java, C++, if you trace back, if you backtrack their development, you will see that everywhere C is the mother. So rightfully, C is often called the mother of all programming languages. Now, what are the requirements in this course, or maybe to study C programming? The first thing that is important, the most important, is compilers. There are various compilers, but I prefer using GCC compiler, the GNU GCC compiler, which is a Linux compiler, but we don't have Linux in every home, so I prefer everyone to use code blocks. Alright, I tell them to use code blocks because compiling and running in code blocks is a bit easy. I tell them to avoid using Turbo C++ because Turbo C++ there are some header files which were actually not a part of the original C. They were made to make it easy, but you can use it. There's no issue in it. You can obviously use it wherever you are comfortable with. But it would be best if you use GNU GCC compiler. Second best if you use the code blocks, and third best if you use Turbo C++. Next is what you need is logics. Computer science is nothing but logics. Let me tell you. It totally runs on logic, and often we say that computer is a device which has got no intelligence but a hell lot of logic. Not nowadays though, because nowadays computers are more intelligent, but they're more logical than more intelligent. And of course we need a lot of patience. Programming is a vast ocean, so to discover that ocean or to travel through that ocean, you need a lot of patience, a lot of perseverance. So I hope you all will show that amount of patience to follow this course. So this marks the end of the first video. In the next video we will start the main course, and I hope you enjoyed it. Please do like the video if you did enjoy, and subscribe to this page for more notifications about new videos. Thank you everyone. Have a nice day.